another episode of A2 Chemistry, and today what we're going to do is A2 chapter 29, Carboxylic Acid and Derivatives. So in this chapter, there's a few things that you guys need to know. First is about electron withdrawing group and electron donating group. What is the effect that it's going to have on the strength of the acid? That's the first thing that you need to know. And also to know the explanation is very important in A2. Always come in exam, by the way. Second thing is what type of carboxylic acid can be oxidized. So please go through it. And after that, looking at the content, we also have the reaction of acyl chloride and how to get an acyl chloride. So that you need to know. And also the most important part is the mechanism of acyl chloride, which is addition elimination. So you guys need to know how to draw your addition elimination reaction, mechanism. Please go through that. And I would say other than that should be all the other reaction of acyl chloride. So please go and memorize everything. And that will be all. So please enjoy the content and jot down every notes. See ya. Bye. Okay guys, nice. So acyl chloride are much oh yeah, last week you at Genting, right? Were you? That's a long time ago. No, last week you was here. Okay, acyl chloride, guys, are much more reactive compared to a carboxylic acid. At this time, much more reactive than carboxylic acid. Wow, Alvina Ho is here. Okay, so guys, the functional group of acyl chloride is C double bond OCl. Yeah. Okay, so the structural formula of acyl chloride can be written as ROCl, where R, right, is just any alkyl group. Okay, guys, why your acyl chloride is much more reactive, right, compared to a carboxylic acid? Let's look at acyl chloride first. You see, right, guys, your carbon in the middle, right, this carbon, okay, is connected to two highly electronegative atoms, you know. So oxygen and chlorine, right, are both electronegative. Okay, so which make your carbon, right, highly electropositive here. Okay, so this is highly electropositive, which means I have one chat coming in. Sir, please send. I'm on iPad. Hey, you're still in Japan, You don't tell me you're still in Japan, Are you for real, Bro, go Japan how many days? Bro can move to Japan already. Insane. What the? How many days? You're in Japan? 2 weeks, 3 weeks, Bro, gonna come back Japanese, bro. 15 days.
Wow, 15 days.
15 days exactly.
This one money printing from free.
Yeah, this one rich kid lah. Wow. So short. What the? Alright, so guys, okay, so your carbon, right, is highly delta positive, okay, which make it, right, very easy, okay, to be attacked by electrophile. Attacked by a nucleophile. Alright, please write it down. Highly electropositive, which make it super easy to be attacked by any incoming nucleophile. 93 pages, of course. Don't worry. Chapter 30 is gonna be 180 pages. Alright, guys, next. Your Cl atom and O atom, right, are highly electronegative, right? So electron withdrawing group. Okay, done. They will attract away. So again, they will withdraw electron away from the carbonyl carbon, and both are highly electronegative, correct? Okay, so guys, next, this gives a carbonyl carbon, right, a partial positive charge. When acyl chloride undergo, guys, whenever we have acyl chloride, okay, the reaction mechanism, right, it's always addition elimination. Yeah, this is something new.
Hey, you told me last week.
Yeah, man.
Yeah.
Yeah, I covered addition elimination, right? No, I haven't covered the mechanism, right? So remember, acyl chloride, okay, the reaction that they undergo is always addition elimination mechanism. Yeah. Okay, so the CCl bond break, a white film of HCl is released. Okay, next. Where Hg, right, is a nucleophile such as any water, alcohol. Later I will talk about it. So guys, your Hg, right, will always have a lone pair. It's okay, all this part I'll talk about it later. So that's it. Alright guys, once done, next page. Okay, right now let's look at the reaction hydrolysis. Guys, looking at hydrolysis is basically you are adding what? A reaction with H2O, yeah. Okay, hydrolysis means you add H2O in it. Okay. And guys, let's continue. So mechanism of the hydrolysis, right? Okay, so you see, if you look at your H2O, yeah, your H2O will eliminate the Cl. Okay, and there's a lone pair here, yeah. So there's a lone pair on oxygen, right? And it will eliminate the Cl. Then eventually, right, your Cl will combine with H, forming a HCl. Okay, so this type of reaction, right, we call it as addition elimination. Remember, any acyl chloride, right, is always addition elimination, yeah. Okay, showing the addition elimination of a H2O across the C double bond O, and after that you eliminate, okay, a HCl molecule. That's it. Food poisoning pool.
How do you feel?
Like Johnny lah.
Alright guys, next. Alright, now yeah, we have a mechanism, okay, that I want you guys to, okay, let's go. We draw it together. Okay, so I want you guys to draw your acyl chloride, C double bond O Cl. So guys, in your acyl chloride, right? Okay, so your carbon is delta positive, oxygen is delta negative, chlorine is also delta negative, yeah. Okay, let's say if I put a H2O here, guys. Okay, so the lone pair of your H2O, right, will attack the delta positive carbon. Bro, not nice. Okay, then the double bond will break. So the electrons will go into the oxygen. Alright guys, now the second part, let's draw it out. R, C, O, Cl. Okay, right now, yeah, you see your O, your H2O, right, is being added, yeah. Alright guys, now, okay, so let's look at it. Your lone pair has to be shown, yeah. You see, right, just now, the double bond broken, right? A pair of electrons goes to your oxygen. You have an oxygen with a negative charge. Next, let's look at this lone pair. Go into the C, which means this oxygen have one electron short, so you have a positive charge. Guys, one more time, you see, the bond break, go into the oxygen, so you have a lone pair and a negative charge. The lone pair go into the carbon, so the oxygen has one electron less, so it's a positive charge. Okay, please write it down. This is very important, yeah. Alright, guys, now the second step. Okay, you have to draw 3 curly arrows to show a direction of electrons. Okay, now you see here, guys, the electrons from your oxygen, right, will go back to here to form back a double bond. CCl will be broken. Okay, at the same time, the hydrogen will donate the electrons back to oxygen. So you have 3 arrows here, guys. Please draw your 3 arrows. Alright, guys, finally, the last part. You see, right, when the CCl breaks, eventually, right, guys, you see, you have an R, C, the double bond O is formed back. Can see that? So this one is also broken, yeah? So you see, this is a COH, right? So your COH is here now. Can see? So your H and Cl will combine together, forming a H, Cl. Done. Okay, this is addition elimination reaction. The mechanism, guys, in your A2, yeah, there's only one mechanism, okay, which is addition elimination. So you don't have to care about your electrophilic addition, nucleophilic substitution, SN1, SN2. No, the only, oh, sorry, that's two. Electrophilic substitution for a benzene. The second one is addition elimination, and this is the hardest, yeah. Okay, so guys, check your direction of curly arrow. The lone pair, the charges must be shown. One more time, lone pair, charges must be shown, yeah. All right, guys, let me ask you a question. Please tell me throughout the reaction, how many sigma pi, how many pi bond is broken and how many pi bond is formed? Look at the entire reaction. If
Oh, 1 pi broken.
yes, you are right, Tanvir. Come again.
1 pi broken.
Well done. So guys, how many pi bond is broken? One pi bond is broken, right? Well done. Oh my god. What the flip? Okay, guys, can you tell me which one is the broken one and which one is the form? Which one is the pi bond? So this pi bond is the one that being broken, right? Am I right? In the double bond, there's one sigma and one pi, right? And when the electrons go back, form back a pi. So remember, yeah, in addition elimination, one pi bond is broken and formed. All right, guys, next, I have another question. How many sigma bond is broken and formed? This is the hardest one. Let's go. Count it properly, yeah. Check it out. How many sigma bond is broken and formed?
Come on, take it.
Okay, I have one answer coming in. Thank you. You got it right. Yeah. How? 6.
2.
Why got 6?
Two.
2 is correct. Guys, where is the 2? Okay. What is a sigma bond? Please tell me now. Sigma bond is a single bond, right? Okay, guys, now, you see, when the electrons go here, the first sigma bond is formed. Am I right? This is the first one. All right, guys, do you see that this sigma bond is being broken? Broken 1, broken 2. Am I right? All right, guys, the last sigma bond is formed. Is here, yeah? Form 2. One more time. You see? Form. Broken. Okay? So in addition elimination, there's 2 sigma bond. Broken and formed, yeah. Yeah. Right. Alright, guys, next.
Actually, I want to go also.
This reaction is more vigorous than the hydrolysis of chloroalkane. Highlight the word. The reaction is more vigorous compared to the hydrolysis of chloroalkane. So guys, the hydrolysis of chloroalkane, right? Later I will talk about it. So I need NaOH equals here. So guys, in addition elimination, right? Okay, a neutral water molecule is sufficient to hydrolyze an acyl chloride quickly at room temperature. Highlight the word water. Highlight the word acyl chloride quickly at room temperature. You see, right? Again, as what I mentioned, addition elimination, right, is very, okay, reactive. Yeah, your acyl chloride is highly reactive. So you put it under room temperature, they will react immediately already. Okay. Okay, next. Okay, this is different due to the carbon bonded to the chlorine atom in chloroalkane not being strongly blah blah blah. Okay, later I will explain all. Okay, so guys, next, if you have an aryl chloride, okay, so guys, let's draw an aryl chloride. Do you know what is an aryl chloride? Aryl chloride is a chlorine attached to a benzene ring. Alright, guys, if you take aryl chloride plus H2O, yeah, what's gonna happen, right? There's no reaction. Remember that. Aryl chloride can never be hydrolyzed. Highlight this word. Aryl chloride cannot be hydrolyzed.
What happened to the sugar?
No,
I don't want to talk to you.
So
We have trust issue now. Alright guys, next. The carbon atom bonded to the chlorine atom is part of the delocalized. Later I will talk about it. Okay, so just highlight this line first. Why, sir? Okay, later I will explain why. Okay, I want you guys to highlight this line first. Okay, then look at page 8. So there's an empty space, right? Alright guys, let me explain the reason why.
You want to eat play practicing more.
Then I say this fat ass bitch one. I was like, I don't know.
Measure.
Purple.
Fucking.
Man, nicely grown.
Suck fuck off, don't be scared.
Alright guys, you see right? Okay, so let's look at chlorobenzene. So again, what did I mention about the ring, guys? Okay, you see right, on chlorine, there's some lone pair present, right? So you have some lone pair here. Lone pair here. Alright guys, what did I mention about lone pair and the ring? Please tell me the story. Yeah, what did I mention about the lone pair and the ring?
Don't pay.
Correct. So again, the ring is like a playground. Okay, so the lone pair, when you say lone pair, what they will do, they will always go into the ring. Remember that lone pair, electron will always delocalize into the pi ring system. So I just want you guys to highlight. Yes, good job. Highlight your lone pair. Highlight your lone pair. You know what they're gonna do? They will go into the ring. Am I right? Yes, sir. So when they go into the ring, right, what's going to happen to this CCl bond? Will it strengthen it or weaken it?
Strengthen.
Yes, correct. So you see, right now your CCl bond is strengthened. You get me? So which is why there is no way for you to break this CCl bond. Guys, remember this, this is a very popular question. Your aryl chloride can never be hydrolyzed because the CCl bond can never be broken. On one reason, the lone pair delocalized into the ring. So this entire delocalized system, right, it looks something like that, Okay, so the entire delocalized system, right, is like that. Okay, despite you drew a ring here, right, but the actual delocalized system looks something like that. Okay, so there's no way you can break this CCl, Okay, it's part of the entire system, so you cannot break your CCl. Please remember this. Okay, I want you guys to write it down. Your lone pair on your Cl atom, what's going to happen? Delocalize or overlap with the delocalized pairing system, right? Okay, when this happened, what happened to your CCl bond? It's strengthened, right? So when your CCl bond is strengthened, what happened to your aryl chloride? Can your aryl chloride be hydrolyzed? Yes or no? Yes. Remember this, aryl chloride cannot be hydrolyzed.
You say yes, I was like, what?
No lah. Okay, guys, this is a very popular exam question. Like super popular exam question. Popular.
Like, not at the trees. Alhamdulillah. I was talking to Sarah about it. I'm not gonna park near the trees, I'm gonna park near the trees. Manifested, I park at the park. Yeah, so I thought we should have what? Then this guy thought I called him a girlfriend. Nice one, my bro. Calm down, my bro. Hey.
Why? Good ma, you have a new girlfriend.
That's fucked up. That's not
You see, Johnny keep cheating the
So can you put some?
huh?
It's 109 and below.
Oh, 9 and below.
Crazy that sound, nah, just kidding.
Oh, nine.
Bro, my hand shaking.
Of course, pretty because like 35 then. How old are you?
It's 30, bro.
30, Look 35.
No, like 28. Yeah. If decimal is not 30,
Oh,
like, he is not.
You're 29.
Bro, if decimal is
Alright, guys.
he's not 30.
Body, bro.
That's
why it's only inside.
For me, that's why your hair was dying, bro.
No, I have hair. Is it my hair? Good, my volume is okay.
Just stop for me.
Alright, guys. The p orbital from the Cl atom tends to overlap with what? With the delocalized pairing system, yeah. Highlight the word p orbitals overlap with the delocalized pairing system. Okay, so this causes the CCl bond, right, has some sort of like a double bond. So highlight the word CCl bond is stronger. Hydrolysis do not occur. Remember, yeah, you cannot hydrolyze an aryl chloride. Yeah? There's no way. All right, guys, now let's look at my reactant. So let's say, right, if I take an acyl chloride, add with H2O, what's gonna happen? Okay, so this, right, you just have to put it under room temp, yeah. You don't even need to heat it up. Just put it under room temp will do. So an acyl chloride will turn into a carboxylic acid. Yeah. Mechanism? Anyone? Addition? Elimination, well done. So remember, guys, any reaction with acyl chloride is always addition, elimination. Okay? No. Coming down, go.
Any.
Not paying attention.
I was writing down, bro.
So again, any reaction with acyl chloride is always addition, elimination. As long as you have acyl chloride, it's always addition, elimination. Okay?
Gone.
Wait, what?
So apparently bird nest thing.
Huh?
Yeah, I think.
Bird nest thing.
But that's all right. Okay, I need to spam it. I'll go.
Greens. The skin is like that.
Sure, what's the difference between aryl chloride and
No,
acyl
it's
chloride?
like
Okay, aryl chloride, right? It's a benzene. Okay, chlorine attached to a benzene. Acyl chloride is CCl double bond O.
Sure.
Bro, you think what? In the zoo, the cage, you're trying to fit me like that, is it? You think what? Circus, ah? I will go catch like that.
I saw you
Ah.
did.
This one.
So you know blueberries they say blueberry very good.
No, of course not.
For the health.
This fellow.
I always put my yogurt bowl.
So you know what you should do? You should buy Greek yogurt, then put all the fruits inside,
Hmm.
and then put protein powder and eat. I saw that on TikTok.
Good yogurt. I have good yogurt. Protein powder, then plus blueberry as breakfast. Very not bad, right? Okay.
So you don't need to add any seasoning or anything.
High. Good. All right, guys. I want you guys to look at page 9, part D. Now.
Protein powder chocolate.
Huh?
Protein powder
I
chocolate.
don't take protein powder.
Serious?
Bro, I have like chicken. You see my
Oh, yeah, you
stupid
know.
ass chicken?
Is that 300 grams or 400?
400 grams, bro.
What the fuck, bro? What the hell?
Or fasting.
Who doesn't? Please tell me. Yours?
Like, oh yeah, like
Yeah,
extra.
because a lot of
Extra
animals.
smelly, bro.
Yeah, extra smelly.
Hey, but Johnny Pot damn loud, no smelling. Actually, sometimes got smell lah.
No, sometimes
Sometimes it smell.
you're lucky that time don't have that.
Remember he
Page 9, part D1, let's go, do now. Oh, yeah, what fat no smell, do lah. Fat no smell.
So you know the time I took a shit in the toilet, right? Then it, like apparently it stank. Yeah, it's kind of smelly. Like it stank damn bad, right? You get to open the door to shower.
Damn smelly.
I could see it's bad.
someone tell me to walk in, you know.
Good luck.
Cause it's bad shit was all.
Oh, shit. Bro, shit together, stay together.
So I had to open the door and shower. I didn't give a shit who saw, you know.
Hey, how half the place saw your fucking ass?
I don't give a shit, bro.
Then you even close what? So easy.
Like, just the ass, man.
Yeah, just the ass cheeks, bro.
I think it's song around the world.
I did sing shit around, bro. You just seeing things.
Alright, guys, draw. Let's go. Alright, draw.
A little secret in my car.
Oh, chill. Yo, chill. Yo, chill. Yo, chill, bro. Calm down. Calm down, calm down. Calm down, calm down.
I can't believe you didn't tell me. To think that I sat on the same page, right?
Oh, calm down, bro. Calm down, calm down.
What the hell do you do?
Okay.
Oh, your langkawi chip
Disgusting, bro.
damn nasty you guys. Alright guys, first delta minus,
It's after you guys need to calm down.
No, after, bro. Not that.
delta plus, lone pair. You can just show one or if you want to show two, it's fine. Okay, lone pair attack here. Double bond break. Correct. Yes, correct, Helen, you're right. Okay, guys, next.
I didn't even bring it out, bro, at this point. This is like a lost cause. I don't.
Okay, guys, go draw the second start. Go.
Put it out.
You lah. Yes, you did.
Put it out.
Oh, this podcast is weak, bro.
Later tell me.
Oh my god.
Must lah, must lah. Must lah.
It's not that embarrassing because it's you, but then.
Yeah, it's you. I'm not surprised. I'm not surprised if
You
you.
expect it, bro. I would be surprised if you didn't.
Yeah, I'm not surprised also.
But I would just hope that you tell me in advance, so that I at least I thought.
Okay. Not that you guys.
Bro, I sat on the same toilet, bro.
Alright, guys, second start. Show your lone pair. Negative charge. Positive charge. Lone pair go back. Form back a double bond. This break. This break. Hannah. No, John. Guys, type of mechanism. What do you call this as?
Addition element.
Thank you very much.
Who knows what else is happening?
Alright, guys, today we'll get this chapter done, yeah. Then we'll move on to nitrogen containing compound. Yeah. Alright, now the next one we have reaction of we done right. Reaction with alcohol and phenol. Guys, if I take a carboxylic acid, react with an alcohol, what do you get? Carboxylic acid plus alcohol. No. Ester, right? Yeah, ester, good job. So guys, the same thing. Yeah, acyl chloride react with alcohol and phenol, you get an ester and a HCl, yeah. Okay, next. This reaction, right, happens more rapidly, yeah. Okay, so Kaylin, what's the difference between arrow, right? Arrow is always with an alkyl. It's always with a benzene ring. That we call it as arrow. Acyl is with a C double bond O. That is acyl chloride. Okay. So guys, with an acyl chloride, this reaction happens more rapidly. Yeah. Alright, guys. For example, alright, guys, draw an ester for me. Go. Alright, guys. Okay, your Cl and this H has to be removed, right? So you just have to join them together by turning into. So you get an ester, right? Can you see that? Okay, and a HCl molecule is formed here. Guys, this we call it as ethanol chloride, right? Because 2 carbon. This one, 1, 2, 3, propan 1 O. So what it turns into, guys, name your ester. How name your ester? That's OES. Alright, guys, next. There is no difference between a carboxylic acid. Let's say if you use a carboxylic acid, right? And a phenol, no reaction, yeah. Highlight the word. No reaction between carboxylic acid and phenol. Alright, guys, still remember in your AS, if you want to make an ester from carboxylic acid and alcohol, you need something. Anyone remember what's the something? Yeah, H2SO4 as a? Yes, well done, good job. H2, okay, it requires concentrated H2SO4 as a catalyst, right? Good job, well done. And you also have to heat it under reflux, right? Okay, so carboxylic acid and alcohol require this condition. Okay, guys, what did I mention about acyl chloride? Acyl chloride is way more reactive compared to carboxylic acid, right? This is more reactive, which means do you need a catalyst now? No, you don't need a catalyst. Do you need to heat? No, you don't. You just have to throw them in, they react immediately. So yes, correct. Under room temperature, they can react. Okay, so this is to prove that, to show that your acyl chloride is way more reactive compared to a carboxylic acid. Understand? Can? Oh no. So with phenol, right, the reaction with an acyl chloride proceeds if warm, Highlight the word with phenol. So reaction with acyl chloride can happen when you warm it. So why acyl chloride more reactive than carboxylic acid? I thought I just explained it here, baby. This one here, right? Now, why acyl chloride is more reactive? Because you have delta minus, right, will make your carbon more delta positive, which means any reaction or any attack by nucleophile is gonna be more rapid. Okay. Okay, guys, let's go. So the reaction between phenol and ethanol chloride isn't quite vigorous. Okay, isn't quite vigorous, but to react a phenol and an acyl chloride, right, you have to turn it into a phenoxide ion first. So guys, phenol must be added into NaOH first to form a phenoxide ion. Highlight this word. Phenol must be added into NaOH to form a phenoxide ion first before reacting with a acyl chloride. All right, guys, let's go. What the hell? Mr. Desmond also getting married, man.
That guy is getting married for damn long now. So who's older, you or Desmond?
You guess,
Definitely Desmond, man.
What do you mean?
Because he got baby face.
Okay, so if I take, put any, yeah, baby face will never age one. I'm so jealous, man. Yeah. So if you add it with an NaOH, right, you'll get a phenoxide ion, correct?
So cannot go for girls that like older guy now. Because they want daddy looking girl. The baby looking.
You look so hot.
Macam
Okay, so these are all the byproducts, which I don't need it. I just need my phenoxide ion. So guys, once I have my phenoxide ion, right, I'm gonna react it with an acyl chloride. Okay, I want you guys to draw your acyl chloride.
wait, Abby, do you know what's the key?
All right, guys, go draw the product for me. All right, guys, let's go. Your final answer. It's gonna turn into what? O C11O C2H55.
It's my mother.
Alright, so guys, again, this is also addition elimination, So guys, reactant and put it with acyl chloride. What 2Cl?
Oh no, it's a lone pair. Sorry.
Yes, it's a lone pair. Alright, guys, you see the condition and reagent, right? First, I need phenol plus acyl plus NaOH, right? So an acyl chloride will turn into a ester. Alright. Guys, the second type of reaction we have, right, is under room temperature. And guys, I can take acyl chloride, add with an alcohol, and turns into an ester. Guys, both reaction, right? Mechanism the same. Addition, elimination. Okay, run to back, right? Alright, guys, finally, reaction of primary with ammonia with primary anime. What the? Guys, change my anime. Sorry for the wrong spelling. Amine. Alright, guys, what is an amine? So again, amine contains nitrogen atom with a lone pair. Yeah. Bro, my editor siao already. My editor onto some kind of crap. What is addition elimination? Addition elimination reaction, right? It's always for acyl chloride. Remember, this is always for acyl chloride. That's it.
Why?
Alright, guys, what turns into?
No good. Yeah, I want to.
That's it. Okay, so guys, from a propanol chloride, it turns into a propane amide. That's it. Alright, guys, next.
Yeah. There you go.
Okay, the organic product is called an amide, yeah. Okay, and guys, amide, right? It does look something like that. C double bond O and H. Okay, this is what we're gonna do later, yeah. Okay, guys, the same thing. Let's say if I take a propanol chloride, and this time I'm gonna add with a methylamine. Guys, methylamine does look something like that. Done. So guys, by the way, this is a CH3. Hey, I draw a structure. Later you guys draw it wrongly. Then you guys ask me why got a stick there. Hey guys, draw it out. What's the product? Go and combine them. Naming why it's fine, but combining, let's go.
I think my gut health is 70%.
Alright guys, what it turn into? Cl and H, remove. Then it turns into an N, H, and a CH3, right? So I join like that, yeah, NHCH3, okay? And plus AHCl. Alright guys, the naming, right? I'll teach you guys how to do it later. Now I just want you guys to write it as N-methyl propanamide.
So today what time we do?
Today, 8:40, 8:30, 8:40. You guys have MX. Right, guys, next. The product is known as an N-amide. Okay, so it's okay. I'll talk about the N-amide next chapter, yeah. Now just chill first. Okay, so guys, take an acyl chloride. I can either react with an ammonia, then it will turn into an amide. I can also react with an amine, and it will turn into an N-amide. Yeah. Guys, I want a mechanism, anyone? Mechanism? Thank you. Addition.
It's just the same thing over and over again.
Yeah, it's just the same thing over and over again. Okay, addition, elimination, kind of. This, I don't need you guys to do it. I just want you guys to do one question with me. Starting from page 13. Let's go. Guys, by the way, this is your exam question. We're going to do one question on one practice to see N-amide. Okay, the N-amide you guys can ignore first. Don't worry, I will talk about the N-amide later on. It's okay. N-amide you can ignore first. We'll do N-amide in detail later on. Alright guys, let's go.
How you mentioned quantum mechanics?
You can grab your foot one. This is a chloroalkane, right? A chlorobenzene. Alright guys, please tell me step 1. What is the reaction for step 1? Step 1 we call it as addition. What type of mechanism? No, it's not addition.
Electrophilic.
Electrophilic. Substitution. Hello.
Sorry.
So hydrogen is being substituted with a CH3, right? Step 2.
Oxidation.
Oxidation, correct. Step 3. Guys, this is AS. Guys, look at step 3. I want you guys to look at step 3. This is AS reaction.
Nucleophilic.
Okay, again, if you're not so sure, right? Yeah, you're most steady. You see? What is this, guys? Can anyone tell me what's the functional group here?
Aldehyde.
Aldehyde, good job. Aldehyde turn into a hydroxynitrile. The very popular reaction in your AS, nucleophilic. No, it's not substitution. Yes, correct. Nucleophilic addition. Step 4. All right, guys, you see, right? From a nitrile, turn into a carboxylic acid. Anyone? Nitrile to a carboxylic acid, also AS reaction. Yes, hydrolysis, acid hydrolysis, well done. Step 5. Guys, can anyone tell me what is step 5? What is this? Mechanism? Or what type of reaction is this? It's not hard. Look at it and think about it. What is formed? A carboxylic acid turns into what? A carboxylic acid turns into an ester. Yeah, correct.
Right.
So which means the reaction is condensed. Good job.
Could you write down? The first one is electrophilic, right?
Electrophilic substitution. All right, guys, finally, you see, right, from hydroxy to a halogenoalkane. So SOCl2. All right, guys, finally, you see, right, this reaction is a bit gay. Okay, from Cl turn into this nonsense. Anyone? Halogenoalkane always undergo what type of reaction? Halogenoalkane, yes. No nucleophilic. Nucleophilic, correct. Nucleophilic what? Well done, nucleophilic substitution. That's it. So you see, right, this is your entire A2 organic chem. Okay, so it's a mixture of AS and A2 all together. Yeah, you have to be very good in your AS as well.
So then the SOCl2 what reaction?
SOCl2 is halogenoalkane to alcohol to halogenoalkane. It's just a normal, still under nucleophilic substitution. All right, guys, now step 2 is oxidation. Okay, next. Write an equation for the formation of electrophile in step 1. Go. Formation of electrophile in step 1.
You know, Manish and all them London.
Yeah.
9 people also, yeah.
Like all guys.
AlCl3 plus CH3Cl turns into what?
Sorry, AlCl4 minus plus
Well done. AlCl4 minus?
CH3 plus.
Well done. Good job. So, guys, the electrophile CH3, right? Include everything there. So, guys, where's the curly arrow at first? Originally, they want you to complete the mechanism. You have to draw this also. Your mechanism there, not drawn. It's from the benzene towards the carbon.
Okay.
So, guys, this side you have what? H and CH3 together, right? Is that right? Middle positive charge.
Yes.
Guys, how to draw next?
Plus 6. Then the H break into the.
Correct. The H break into the ring. Alright, guys, let's continue.
I don't think Michael got her that expensive.
Yeah.
Okay, step 2 is an oxidation reaction, right? So, guys, they want you to write down an equation. Guys, please tell me what is the molecular formula here? C6. 1, 2, 3, 4, 5, 6. How many H? 1, 2, 3, 4. H4, Cl, CH3. Is that right? Copy this. Write it here. Plus a square bracket O. It's gonna turn into what? Guys, go. Count. This will be what? C6. H4, Cl, CHO, right? Correct. Okay, go. Alright, guys, balance the equation. Please balance the equation for me now.
Equivalent is this now.
I really wish there was like say someone that I
You can
Girlfriends are guys.
Yeah.
Alright. It's so sad.
Alright guys, you see right? Your C6H5, H4 never change, right? Cl never change, right? C, you added one O in, the two hydrogen, right, is gonna get removed as H2O, right? So how many oxygen do we need? Two lah. 1, 2, right?
Oh.
Done.
Now okay lah.
Alright guys, next. Suggest reagent for the conversion of K to M in step 3 and 4. K to M.
Where is it?
Guys, nucleophilic addition, still remember? No, like, yeah, go.
Wait. I didn't even see the reaction.
Never mind. You still have your organic head sheet, right?
Yes. Teacher, wait, let's guess.
AS organic head sheet.
This is so boring. I should be guessing.
Right, go. Carbonyl compound. Turn into hydroxynitrile. Correct.
I know this.
At nucleophilic addition, go.
I know this.
Please tell me.
The HCN trace amount.
HCN with trace amount of KCN. Well done. NaCN, KCN. Good job. Nice. Wow, not bad, huh? Wow. Alright, good. Guys, let's write down. KCN with trace amount.
HCN trace amount.
Yes, HCN with a trace amount of
NaCN or HCN?
NaCN or KCN also can. And heat, right? Correct. So guys, you see, the funny thing is, your AS reaction, do not forget, which is why I move on to organic immediately, because you need all your AS reaction. Okay, guys, step 4. How do you turn a nitrile into a carboxylic acid? H2SO4. Well done, good job. Do you need any other condition? Okay, carbonyl compound. Nitrile is here. Nitrile turn into carboxylic acid. H2SO4, HCl, okay. H2SO4 is okay. Then you need to heat under reflux. And see that? Nitrile to carboxylic acid. That's your AS reaction as well. Go.
So H2SO4 and I write diagonal.
It's okay. You can write any H plus.
What was the H2O?
Because I need to show that it's a hydrolysis. Alright guys, step 5. What's step 5? We already label, right? Ester is condensation, right? Go.
Just now,
Okay, we are almost done with our organic chem already. For info, we are 75% done with organic chem. Yeah. Okay, that will be all for the class today. If you have questions, ask me now or else. Bye-bye. See ya, guys.
Please like and subscribe. Please like and subscribe.